Hi, I'm Basta, and the project that I've been assigned is real-time AI-powered exercise evaluation web app. So I've built it using HTML, CSS, JavaScript, and MediaPipe along with Three.js. So let's take a quick walkthrough of the code to understand it, and then I'll be working through the demo. So this is the main index.html file whose components will be rendered on web. So initially we'll be attaching few links that will help us use Three.js and components from Material UI. And these are some generic styles that will make our website decent. So starting from here, we have two buttons which says start squats and start push-ups, which will track the squats and push-ups that we do in real time. And then there is a division which will count the repetitions of that particular exercise and a button to enable the webcam. We also have a feature that I wanted to add, that is analyzing an image if it's a perfect squat or push up. So for that, we'll be having an having two input buttons in order to upload the images of squats or push-ups. Then we have the style.css file, which will pretty much provide styles to the website to make it look neat. So this is the main file, script.js, and I'll be walking through script.js one by one. So firstly, we import the necessary libraries and we get the necessary elements that we will have to work with later in the code. We define few variables, and here we'll be defining the threshold angles that we'll be using to compare for correctness of the squats or push-ups. Like for example, if the calculated angles fall within these thresholds, we'll determine it to be a correct push-up or squat, else no. We also define two colors, red and green, to determine the correctness of the exercises. The first function is initializing a Three.js scene, which will help us render the 3D scene on our web. We also create a renderer that will draw everything on the scene using WebGL. And then this animate function is called over and over again in order to maintain that smooth transition between the scenes and ensures that scenes get rendered over and over again. So this function called create text sprite is used to lay a 2D text label on the 3D scene. So for that, we'll be creating a canvas and drawing text onto it. So once that is done, we'll be converting the canvas into a texture, which is then applied to a sprite material. A sprite is nothing but a 2D image that always faces the camera, and we'll use this sprite material in order to render this text as an image on the 3D scene. So this function is update annotation, which is not used right now because we're using a much more useful function than this. It just updates the annotation feedback that we get from evaluating squats or push-ups, and a function for clearing this annotations out. So this function called calculate angle 3D is used to calculate the angle between the landmarks that we detect. And for squats, it might be knees or hips, etc. And we will be using the dot product and some mathematical formulas in order to calculate the angle between those vectors. So this is the function that detects the exercise and evaluates it. So initially we'll be defining all of the landmarks irrespective of the exercise that we get. And we identify the type of exercise. Like for example, if the exercise is squats, we'll be calculating all the necessary angles and we'll be comparing them with the thresholds that we defined earlier. So if all of these angles fall between these thresholds, we'll be determining it to be a good squat, else no. A similar approach is used for push-ups as well. So this show in place feedback is the one that helps us render those text on the scene. So it calls that sprite function that we discussed earlier, and it will lay the text on the 3D scene according to the feedback that we get by evaluating the exercises. So this create pose landmarker function helps us load the required model for us. So in order for this pose landmarker light model to work, we'll have to load some tools before, and this line of code does it. And once they're loaded, we'll be loading the model as well. When all of these steps are done, we'll be removing the invisibility marker that is placed and we'll render those landmark detection on the screen. And this is some event listening code, and we'll be adding on-click event listeners to the buttons that we discussed earlier. And for squats, we'll be defining its corresponding work, and for push-up, we'll be defining its corresponding work. So once we're done working with these two buttons, we'll be working with webcam button, and it also has an event click listener. And once the button is clicked, the user will be prompted to give access to webcam, and once he does, we'll be start detecting the landmarks on the screen. So this enable webcam functions pretty much controls the webcam, and if it is running, it will set back to false and it will change the button text. It pretty much works like a toggle button. We can also set the width and height of the video. So this predict webcam function is run over and over again, and each time it runs, it checks for the landmarks and draws over it. We also have a resize event listener that will come to help when we resize the window, because we don't want the landmarks to be improper when the window resizes. So this is the image upload logic that I want to include. It pretty much takes an image and it will have squat or push up, and based on the image that we got, it will determine if the particular image is a perfect squat or not, or a perfect push up or not. The evaluation remains pretty much the same, and we'll be having some conditional statements here in order to determine if it's a good squat or not.